Radiomatrix material is available on two of our platforms. So it's mainly on any of our systems that are considered our digital anatomy printers. So Stratasys has two digital anatomy printers. We have our large J850 digital anatomy printer, and then now we have a smaller platform, our J5 digital anatomy printer. Both of those printers are the only ones that offer biocompatible materials. They also offer our TissueMatrix material, our BoneMatrix material, an easier to clean small vessels like a GelMatrix material. There's a theme going. And then also now our Radiomatrix material. And so these materials will allow you to make models that fully mimic bone and tissue-like properties. I'll share with you one of my favorites that I have. This is showing you can literally print a model that will show off your porosity of your bone. So an actual, what your bone might look like, you can go anywhere from healthy bone, osteoporotic bone, it'll change the pore sizes. You have a soft tissue-like material. We have settings where you can create something that might mimic how a tumor would be. And now you can do the same thing with radiopacity. And these are in our GrabCAD software. It's easy drop downs, we'd call it. So you can say, I want anywhere from, our materials will print from a -30 up to 1,000 Hounsfield units. And you can say you want to print on the low end of your Hounsfield units, and then the printer will give you your mix options you can create. And then you do the same for your higher Hounsfield units. Another sample I can show is, here's just one of our marketing models for a heart. But as you can see on here, there's different colors. Each one of these colors is come from what we'd call a different STL file. These STL files almost know their coordinates, you could say, that when designing a model, it knows where they lay within each other. You drop those all together into our software, and just like I could pick now different colors on my model, I could do the same with different Hounsfield units. So it is completely user-friendly and open to an operator to pick which settings they would like to use. And these settings tend to range from just like standard what you'd see in industry of, as I mentioned, like what a bone range might be, or blood is anywhere from like 13 to 50 Hounsfield units. So you can pick these different settings yourselves, and the printer will consistently recreate that model for you the same way every time.
So how did you get into printing the bio materials? Like, were there challenges in making those machines?
It's a good question. I'd say the biggest challenge was finding materials that are soft enough, mainly to truly mimic tissue-like properties, but our printer heads could still handle. The softer it is, the more liquid-like. And more liquid you push through something, the more chance for any form of clogs and issues. So I'd say the biggest challenge with our development teams were how to get materials that feel as soft as possible to mimic native tissue, while still allowing our printers to consistently print those models without any problems.